Andy Kamashian from Southern Fabricating Machinery Sales, our guest on Blackbird TV, all about press brakes. Hi, Andy. How are you?
I'm doing good, David. How are you?
You know, it's a beautiful day in the neighborhood. Andy, press brakes, all kinds, all shapes, all flavors. I'm an appraiser. I see lots of different pieces of equipment out there. What does a press brake do?
Well, a press brake is a machine that's utilized to form sheet metal into various things like boxes, enclosures, lids, pans, any kind of part that's formed from sheet metal. They can also be used for punching, but that's a very, very limited application that they do. Typically, that'll be done offline on a laser or some other system.
Andy, I see a lot of these press brakes out there with these giant flywheels on the side of them. What's with that? It's a mechanical, right?
Correct. Mechanical press brakes were really some of the first ones that were developed, back in the early days and served very, very well. They had a unique purpose at the time to be able to form metals, but they had such limitations. They were very difficult to control the ram. That's the up and down part that holds the punch. And that means that it was very hard to control the angle of what was being formed. So what you had was every angle you wanted to make in a given piece of material, you had to have a separate die to make that angle machined at the angle you wanted to make. And so the mechanical brake would come down and just hammer that material into the bottom of the die and create that. So if you had multiple angles in a part to make, you not only had multiple dies, but you had multiple setups to make. They just became more and more difficult to use as technology advanced and developed. There's one advantage that mechanicals do have, though, and that is punching. So if there is and again, they're very limited application, but if there is a need for a customer to do punching over a long, 10-foot piece of material, mechanical brakes are very well suited for that because of their design, their rigidity, and their ability to absorb that shock, that impact from punching.
I'm an appraiser. I see a mechanical brake. Has it got value?
Very little. Again, the very, very small margin of customers have a need for that kind of machine. And the flexibility on those are so low that it's typically something that as an appraiser, you're not going to see a lot of value in. And as a used machinery dealer, we don't see a lot of value in either.
You're not stocking any mechanicals at Southern?
Not today.
Okay. So technology progresses and in comes probably a hydraulic version of that. So talk to me about that. I've got this picture here, this Trump press brake. This is a relatively new one. It's a 2020, actually. Let's talk about the hydraulic press brake.
So hydraulics really changed the way that brakes were built. And they were actually a lot cheaper than all the machining that took place on the flywheel and crankshaft of these mechanical machines. You could simply add hydraulic cylinder as a hydraulic power source and control the press brake. And that became initially much cheaper to build than the mechanical press brakes. And that's where our first hydraulics came in. Little by little, we began to gain technology with hydraulics. We got better at accuracy. We added servo hydraulics. We added scale feedback to the machine. So we were able to know where the ram was at as opposed to where the hydraulics were telling it to go. The CNC controls added to the machines controlled all of that. And now we could control the ram depth. And that means we could control the angle of our bend. By doing that, we could now have one set of dies. Our tooling costs were lower. We could have multiple bends in a part. Our setup times were faster and our production times were faster. And we just simply got more parts off the machines. And that was really about the death of mechanicals at that point. Really just, they were so far advanced, we just couldn't see that. And hydraulics took that technology to the next level.
Interesting perspective. I never realized the tooling had so much to do with it relative to the downstroke pressures, and it makes all kinds of sense from an operator's perspective and trying to get that part out. What other kinds of energy are used to bend that metal? What other kinds of press brakes are there, Andy?
Well, they're powered in a number of different ways. Some of the very small ones, just so we cover all the bases, are there is manual press brakes or pan brakes, we might call them. Again, very thin sheet metal used for roofing and trim applications. There are air-operated press brakes for very small applications. But in most shops, you're going to see hydraulic. You're going to see a version of hydraulic called hybrid. You're going to see electric press brakes. I'll explain the hybrid press brakes first. Typically, what we had with hydraulic press brakes is a large hydraulic power source, a large pump, reservoir of 60, 80, 100 gallons of oil being pumped throughout these various lines to the hydraulic cylinders on the machine. And those would be fed back with servo hydraulic valves as well as closed loop systems to the control. And it worked quite well. The ability to reduce all of that oil and all of the lines and all of the time it took to actually move the system was changed when they developed a hybrid system. And that was simply a very small hydraulic power pack right on top of the hydraulic cylinder or located close by. And those systems became very accurate. There was less oil. They're very quick to respond, and they don't run until there's a demand for the cylinder to be moved. Was very, very efficient design. And that's right in between the design of full hydraulic machines and then also the design of electric machines. Electric machines allowed us to create the tonnage that we needed for most applications. They limited about 300 tons. And that allowed us to do that with simple electric drives. Very quiet, very cool. So we didn't have the hydraulic oil that was heating up and having to blow all that heat throughout the shop. And they were very accurate. So the electric brakes became a little bit more advanced in that lower tonnage. And the biggest thing that they brought to the game was they were super accurate. I mean, super accurate. They were just much more accurate than even the hybrid hydraulic machines could be.
We're in a world now that is super energy conscious. Which one of these machines uses the least amount of energy and is the most efficient?
Typically, you're going to have the electric and pretty close to the hybrid machines as they only run their motors on demand. Whereas the older hydraulic machines, you've got that hydraulic pump always running. It's always on. It's always ready with full pressure. But typically, your electric and your hybrid brakes, they're pretty close to each other as only running the pumps or drive motors when it's demanded.
And from a description perspective, again, is the appraiser looking at these things? Fundamentally, what do I need to write down? How do I describe it? What do I need to write down so that I can form an opinion on whatever it is that I'm looking at?
Oh, that's a tough one. Obviously, condition control. There's a lot of variants of these machines, particularly over the last few years, whereas many companies have popped up and all of a sudden came to market very quickly, albeit too quickly in some cases, with their variant of these new technologies or these newer technologies. Some of the mainstay brands that you might think of are a bit better at it. It's just tough to say, if there's a particular aspect of machines that you would look at for determining value.
Just to write it up, length, bed length, the gap, tonnage, is that enough?
Well,
obviously serial number and manufacturer, that kind of stuff too. But when you describe it,
basic description of the brake is going to be what we're looking for is I need to know what tonnage the machine is. So that's number one. Tonnage tells me the capacity. What can I bend in this thing? Whom can I offer this to? Whom would be interested in it is by the tonnage. More tonnage, typically the more value that the brake has. Overall bending length, that's the width of the brake. And the width of the brake is somewhere in the 2 foot, 4 foot, 6 foot, 8 foot, 10 foot. Again, that's going to determine the overall value of it. As the wider that brake goes, the more capacity, the more I can put through it, the more market appeal it will have. The other part is going to be the number of axes that the machine has. In the past, we wanted simple machines. We wanted a machine that just did one thing. Now, our CNC controls have the ability to do so much. They do so much thinking for us. They do so much positioning, and they repeat it each and every time. So the more axes that I can get on a press brake, which controls the flange length that's being formed up, it controls any kind of compensation for deflection of the die, and it controls various other things, is going to help the operator get more productivity out of that machine and certainly make the machine more valuable.
All about press brakes. Andy Kamashian, Southern Fabricating Machinery Sales. You are the man. I appreciate your time today. Thanks for joining us.
Thank you, David.